In the past 2 years here at ANSYS, we've been working very hard on our R16 release. We had more than 1,200 people, designers, engineers, developers, testers, working on the most creative, most innovative, and most feature-rich product we released in our history in the last 45 years. So today, I'm going to take you through just key highlights of some of these features on each one of the major product families. So let's start with structural. In this area, I want to highlight 3 key innovations we had. The first one around thin structures. We worked with our customers heavily over the last 2 years to understand what are the key important things to them around thin structures. And a key theme came up around meshing and ability to actually model and mesh these thin structures in a way that allows the solvers to drive them and give them high degree of accuracy. So over the past 2 years, we've been working in this area, and we made a tremendous amount of innovation in our meshing technology and our ability to actually reduce the time to actually solve these problems insignificantly. Second part of innovation is composites. We all know how important composites are for today and for the future of manufacturing the materials. This is an area where we have an incredible competitive advantage with our ACP product line. What we've been able to spend over the last 2 years is work even closer with our users and our community and our researchers to make sure that we have the most advanced pre-processing capabilities and our ability to make sure that we simulate really 3D simulations, very high fidelity simulations of composite materials in real world scenarios, and ability to actually mix composite materials and non-composite materials and regular materials together in a single simulation. So we're very proud of that innovation. Third, elastomers. Elastomers and our ability to simulate different rubber materials, as an example, and seals is something very critical. Our ability to get contacts right, our ability to get robustness in the systems, our ability to make sure that when you have rubber seals across different type of scenarios are simulated accurately is very critical, especially with the new applications coming up, with the new forms of applications where seals are critical to the future of product development. Second, let's talk about our electronics products lines. In this area, I also would like to highlight 3 areas. Wireless communication. We all heard about Internet of Things. Internet of Things is really a new revolution. It is the way that the future is going to be. We're going to have massive amount of sensors, and all these sensors are going to need to communicate. So everything is going to need an antenna, and there will be a lot of wireless communication happening between different components of systems. To this end, we worked very hard on creating a single integrated environment. This is a key here. It's a single integrated environment that allows the users to simulate different behaviors of different sensors and communication patterns in one environment. It takes advantage of modern UI, it takes advantage of scalability that nobody else has, and it takes advantage of our great 3D physics. Second part of the innovation around power integrity. In this area, we've worked very hard to make sure we give the users a view into 3D physics and allow the user to be able to optimize for power integrity across a board or across a chip. Third part of the innovation, custom libraries. This is an area where it doesn't go into actually simulation, but we believed it's very important for us to address this area. It's around supply chain. We understand that the market and the designers sometimes want to collaborate and they want to communicate with their supply chain, but they don't want to necessarily share the entire product design with their partners. This is a mechanism that allows them to actually take a component and make sure that it is built into library, make sure it's secure, and make sure it's encrypted, and share that library or that component library with different suppliers, and allow the suppliers and the designers to interact with that as a black box without cracking inside the black box and protecting the IP. So we think this is a great innovation for this industry. Now let's talk about our fluids product lines. In our fluid product lines, 3 areas of improvement that we made a massive improvement in there. Number 1 is pre-processing. When we did a time and motion study over the last 2 years, and we wanted to understand where our users spend most of their time, we found that a significant portion of their time, sometimes up to 70 to 80% of the time, spent in the pre-processing area. This is for importing geometries, this is for meshing, ability to handle meshes, ability to morph a mesh and change a mesh. We spend a significant amount of time innovating in this area. We took a real workflow, a real life workflow, and we were able to cut that workflow by 40%. And this is what you see in R16. Optimization, that's the second part. We are known to be the most scalable company when it comes in this area in simulation. It's well known that we are certified in our fluids business to be 36,000 cores on a Cray supercomputer. But we're taking this to the next level. We want to optimize the entire process. We work, for example, on technologies like our adjoint solver. We had adjoint solver for the past few releases, but in R16, our adjoint solver innovation lets the mesh and lets the solution drives the design. So you could optimize in a significant way in areas where you were not able to do that. At the same time, using our high performance scaling and high performance capabilities that we have in the product line. Turbo machinery. We're known for our turbo machinery work. We even perfected that more. We now allow you to use many more models. We know now you want to be able to do different kind of flows and different kind of models. The depth and breadth of physics in our turbo machinery is unparalleled. No one else comes even close to that, and we're going to continue innovating in our turbo machinery work in there. Another innovation for us in R16 is a new manifestation of our workbench environment. And our workbench platform, we call it AIM. AIM is a single, modern, and state-of-the-art user interface that allows a designer, a user, an engineer to be able to simulate and model a multi-physics problem in one single environment. Smart user workflows. This is an area we work very hard on making sure that we equip AIM with a lot of templates and workflows that allows engineers or entry-level engineers or designers that have not been exposed to simulation before to be able to pick up the product and be able to start working on real-world problems very quickly, very easily. Another key innovation in AIM is our customization. AIM, as I said before, it is really a manifestation of our workbench platform. So it's built on top of a proven technology. It's built on top of our proven solvers and proven meshing technologies that we've been doing for the last 45 years. But one other key element in here is we opened up the interface for AIM. AIM, you could actually pick it up right now and be able to write applications, customize the interface, and customize the workflow to your needs. So it is truly a manifestation of a platform that is very powerful. And just remember, it gives you access to all the ANSYS meshing technologies, all the ANSYS geometry technologies, and a significant access to our most powerful solvers on the planet. Thank you very much.